and material handling operations. When transporting large bulk of material, it is crucial to do it efficiently. So these images in this slide show different transportation methods commonly used to transport iron ore, also coal, and other bulk materials. Although these three transportation methods have similar purposes, they are different and the way they operate. So for example, for unloading wagons, they use trapdoors. Bulk carriers use grab buckets, and river barges use bucket unloaders. So what it can do is to perform visual testing of transportation equipment. For example, ensuring efficient loading and unloading, predicting charging and discharging times, and all these would help to prevent spillage and forecast maintenance time. So let's look at one example in more detail. Here we can see the coal wagon being loaded with material from the top and unloading the material into a hopper through trapdoors at the bottom. Some areas of analysis could be loading and unloading time, so you can predict the force on trapdoors. And knowing the pressure on the doors will allow the design of the shutting mechanisms. Another important parameter is wear, that is caused by material friction. So it's important to understand the wear levels that will be expected on the equipment surface. And this will allow to plan maintenance periods. And also put into place solutions that minimize equipment damage. For example, using different materials or equipment design. So this slide also shows additional areas of analysis, such as spillage and segregation. Next stage, after a design issue is identified, is to conduct a simulation to establish which is the best design approach. This video here demonstrates that there is a design problem with material flowing under gravity. The graph on the right indicates the amount of material in the wagon at any point and shows that the material reached a steady state after 15 seconds. However, roughly 2 tons of materials are still in the wagon, and that's the issue. Because this situation, ideally, you want all the material flow out naturally. Otherwise, it will have to be removed manually or use a machine to do it. So here we have a suggestion, an improved design, which includes 2 inclined plates that are colored in orange to help draining the material at the ends. So the video shows that the solution will be effective, since all the materials slide into the hopper and the discharge efficiency is around 99%, which is 25% more than the previous case. However, the main point of these 2 examples is to highlight how Eden can help to optimize the equipment design. Because we can also notice that this new design can only transport around 75% of what the previous design can. Therefore, the best compromise in solutions has to be found,